All right, good morning, everybody, to this, I believe it's Wednesday. I have to think about it. Where we are just wrapping up our discussion on factors and multiples. Now, we talked about the greatest common factor, and we just have the other side of that discussion to wrap things up, and we'll start with an example in 11.3. I just want to check just to be sure. Can everyone see and hear me? Just let me know in the chat. Then I know there
Yeah.
aren't any technical difficulties. Okay, thank you. Just paranoid. Okay, so let's read 11.3. Hot dogs are sold in packages of 10, while hot dog buns are sold in packages of 8. How many should you buy of each so that the number of hot dogs is the same as the number of hot dog buns? Okay. So let's have a look here. Zoom in. Okay, so we have in example 11 points. That was supposed to be a 3. 3. Okay, so we have hot dogs in packages of 10, meaning that I will only have hot dogs as multiples of 10. I can have 10, I can have 20, 30, 40, 50, 60, and so on. And hot dog buns are going to come in packages of 8, so I'll ever only have 8, 16, 24, 32, 40, 48, 56, and so on. I want to now know how many do I have to have of each so that the numbers match. And we can look from this list and see that 40 is the first number, the lowest number that matches. So we call this 40 the least common multiple of 10 and 8. So when we look at the multiples, it is the smallest one that is common to both. So again, we have this 3-word concept, and we'll write LCM, least common multiple, and then of course the numbers in question need to be mentioned in brackets, and the answer is 40. Now, this is different than the greatest common factor. We had a factor list. Now we have a list of multiples. But the same issue is there that if my numbers are small, then great. I can get little Timmy to make a list of multiples. It's good practice for him anyway. But as soon as these numbers just get a little bit bigger, then making this list of multiples are going to become it's going to become tedious. And it might take a while before I find one that's common, let alone the smallest one. So again, I want to know, well, what makes these numbers behave the way they do? What are their building blocks? And can I exploit that to figure out what the least common multiple is? Now, the least common multiple is used in things like fractions and things and situations like that. Uh, it has a purpose. I need to be able to find it. But when the numbers get bigger, this method doesn't seem that efficient. So let's instead, just like we did for the greatest common factor, look at, well, what's the prime factors of 10? Well, luckily it's a nice small number, so it's easy to find. 2 times 5, and 8 is going to be 2 to the power of 3. So then I want to use this to construct, to build the least common multiple. Understanding what I'm looking for. I'm looking for a multiple of each one. Meaning now, in contrast to the greatest common factor, where I was building a factor requiring it to fit into each of my numbers, it's now the reverse. My numbers must fit into this multiple that I'm making. And in order for 10 to fit, I need to see a 2 and a 5. And in order for 8 to fit, I need to see some 2's. So all the prime factors that I see among the numbers need to be in this answer that I'm making for those to even have a chance to fit. It has to be common, so I have to look at all the numbers. But I want to make it as small as possible. Now 10 says, yeah, I'm happy with 1, 2, and 1, 5. If you have that in your multiple, I'm going to fit, I'm happy. 8 says, well, I don't care about the 5. I need to see 2's and I need to see 3 of them or I won't be able to fit. So I need to up the number of 2's to 3. I'm trying to keep these as low as possible, least. But I can't go any lower than 3 2's or 8 won't fit. So the best I can do is that. Now I can calculate the answer if I want to. I don't want to. But if you have a need for that, you can punch it into your calculator, see what the answer is. That answer, that final number, that calculated number doesn't mean anything to me. The components of the answer means much more. So I definitely don't want to skip that step. Now, all we have to do really is just practice this concept and the understanding of how to build this least common multiple using the prime building blocks of each number in maybe slightly bigger examples. That's all we need to do. Are there any questions at this stage? There's our example, or exercise rather. So now I'm going to use the same numbers as I did before, because we have the prime factorizations for them, and then use that to find the least common multiple. But of course, in my infinite wisdom, I do not have my notes from yesterday. So I don't remember what those prime factorizations were. I'm going to need your help. So for the first one, we need to know, and I don't want to redo the whole factor tree, right? We've done this. Now 10 would be 2 squared times 5 squared. That one is easy enough to remember. 240 had its own prime factorization that we did yesterday. I just don't have the notes in front of me, and I hope that you do. And if you do, please tell me what the prime factorization of 240 is, because we're going to need it, and I don't remember what it is. Can someone tell me what it is? Anyone at all? Don't be shy. Surely you took notes, and you can quickly look it up. I delete all these slides after I write them, so I do not have them. And I don't want to waste your time doing the factor tree that we did yesterday. Can someone please tell me what the prime factorization was that we got yesterday? Anyone at all? This is not a hard question. We did it yesterday. Okay, then I have to do the factor tree, and I apologize for wasting your time because we've done this yesterday. But maybe you want to see the factor tree again. Oh, there it is. Someone responded finally. Let me back this up. All right. Well, which one is it now? 2 to the power of 4 times 3 times 5, or 2 times 3 times 7 times 7? Why are there 2 of them? Now I get 3 different answers. In Discord, it says 2 cubed times 3 times 5. First chat in YouTube says 2 to the 4 times 3 times 5. Why are there so many different answers? Don't we just look it up? Now I don't know. I have no confidence anymore, so I'm going to have to go calculate it. 2 to the 4 times 3 times 5. That seems to be the winner. I'm now suspicious. Let's calculate it. Be sure. 2 to the 4 times 3 times 5. Come on, MathBot. Save us. 240. Thank you. Okay. Whew, that was harder than it needed to be. Okay. So regardless of how we get it, we need the breakdown of the numbers to then build our least common multiple. Now, sometimes a question will just straight up give it to you, and the task is only to use that. Sometimes you have to use the factor tree or whatever means you want to find the prime factorization first and then move on. It depends on the question. So now I'm building a multiple, which means I need to see 2, 3, and 5s. I don't care how many right now. Just want to make sure all the prime factors that I need are in there. 100 needs to see 2s and 5s. Done. 240 needs to see 2s, 3s, and 5s. Okay. Now, so that makes the common part, multiple, common. So both can fit. If I have enough of them, and I want to keep that down, make it as small as possible. 100 says, well, when it comes to the 2, 100 says I need 2 2s. 240 says, no, I need 4, or I'm not going to fit. So I'm going to have to go to 4. That's the best I can do. Any lower, and 240 will not divide into this number anymore. So it's the best I can do when it comes to the 2s. When it comes to the 3s, 100 says, I don't care what you do. I don't even need to see it there. But 240 says, I need 1. Yeah, sorry. So 1 is sufficient. When it comes to the 5s, 100 says, yeah, I need 2 of them. 240 says, I only care about 1. So with 2, I'll make sure that either one of them can fit. Now, they don't fit at the same time, so I don't have to add them up or anything. Just 100 needs to fit into this, period. 240 needs to fit into this, period. So it's 2 separate checks. Calculate that, don't calculate that. You'll see I never calculate it. I want to see how it's done. Any monkey can punch that into a calculator and find the number. That number gives me no insight into what makes these numbers tick and how do they work. The prime factorization, the building blocks tell me that. Any questions on how we build this least common multiple? It's not a super hard concept. Now in elementary school, we certainly start with a list of multiples, list of factors. We don't jump to prime numbers, but just like anything else, uh, once your numbers get bigger, the basic elementary method is just not going to work, and you need to step it up accordingly. Question in YouTube, do you have to put the exponent for the 3's in the final answer, or can you leave the exponent blank? No, you can totally leave it blank. If it's a 1, you never have to. You never have to show that. But you're welcome to if you want to. Totally up to you. Doesn't matter. If there's nothing, then it means it's to the power of 1. So let's try another one. And maybe this time we'll have a little bit more success with getting to the prime factorizations, though it was very entertaining to see all the different things that we came up with. 702 and 294. Now we've done these, which is the only reason why I'm not doing them again, to save time and do not annoy anyone. If we haven't seen these numbers before, then of course, do the factor tree, do the whole thing, you need to be sure. But these were exactly the numbers we did yesterday, So we can just look up what we did yesterday and find the prime factorizations. 702 has a prime factorization of what? I can't do the factor trees in my
It's
head that
2,
fast.
3 to the power of 3, and 13.
3 to the power of 3 and 13, like that?
That's what I have here.
Okay, good. And 294? Stephanie's typing. Oh, she beat you to it. 702 is confirmed. Good. Confirmation is good. We still need 294.
That's 2, 3, and 7 to the power of 2.
7 to the power of 2. All right. Now, once we have these building blocks, we can build our least common multiple. 237 squared. Perfect. 294. Okay, so now I'm trying to build this. Understanding is all I need. I'm building multiples of each of these numbers, so I'm going to have to see all the prime factors that appear because it has to be common and as well as a multiple. Then I worry about the least part. Now I know there is not a multiple yet until I finish the exponents, but in the process of finishing the exponents, I want to keep the least in mind. That I don't want to just slap on many 2s, 3s, 7s, and 13s. I want to keep it as low as possible while still making sure any one of these numbers can fit when they want to. So when it comes to the 2s, each of these numbers say they just are happy with 1. 1, 2 is fine. Write the 1 there. I write the 1 just to indicate that I have finished considering that one. But of course, you don't have to. Next up is 3. 702 needs 3 of them when 294 only cares about 1. So I'm going to have to up it to 3 to make sure any number is happy. When it comes to 7, 702 says, I don't care at all. 294 needs some 7s, and they need 2. When it comes to 13, 294 doesn't care, but 702 does, and only needs 1. So again, the 1s are optional, but there's no harm in writing them. You can always write them. And there we go. Once I understand what the L, C, and the M are asking me to do, then it's just a matter of using the building blocks and the right number of them. Now I'll contrast this with the GCF. I don't have notes. I'm doing it as if for the first time, just to see how's the thinking different and how it's the same. So now I'm looking for a factor of both of these numbers. So I'm making something that can fit into both of those. So I am going to only look for the common prime factors because if I have a 7 here, it's not going to fit into 702 anymore. If I have a 13, it won't fit into 294. So I need a factor, and a factor of both has to be common. And I'm trying to make this as big as I possibly can. But if I have too many 2's, I won't fit. And each one can only handle 1 2. So 1 is the best I can do, unfortunately. I'm trying to push that as high as possible. Whereas in the least common multiple, I'm pushing it as low as I can. And when it comes to a 3, 702 is happy with 3 of them, but 294 is only happy with 1. So if I up the number of 3's, I can't fit in there anymore. So unfortunately, 1 again. So these are very different in the thought process. Factors and multiples are not, in general, the same. So it's very important to separate these two concepts in your head to understand why is one's argument a certain way and the other one is a different argument for how to make these answers. All right. That is pretty much it for this chapter. Are there any questions as I bring up the problems just to see what they look like? Practice these problems as you feel you need to. They are there for you. I like 11.1. At least scan through it and think about it. Just to decide which numbers are prime. It's always surprising how people miss the obvious, but I won't ruin it for you. You have to think about it first. Then I can practice some factor trees. It's specifically going to say, as well as in the test, use a factor tree. So again, just finding the answer, that's only half the question. You have to use a factor tree and then find the prime factorization. So you can practice however many you want of those. Then in 11.3, we can use prime factorizations to practice greatest common factor, or sometimes called greatest common divisor, least common multiple, sometimes called lowest common multiple, just like we just did. All right, so we didn't quite have enough time to fit everything in yesterday, so we needed another day, but we didn't have that much to do. So for the remaining time, I'll hang around to see if there are any questions, but I don't want to get ahead of the schedule. We'll start the next chapter tomorrow. That is all I have for today. Practice if you need to practice. Do what you need to do. Ask
Thank you.
questions. Thank you. Again, like I said, I'll turn off the screen, but I'll be around. If you have any questions, just let me know in the chat. The time is there for you to use however you need to. But if I don't hear from you, then I will talk to you tomorrow.
I was just wondering about the oral test there or whatever. Is that just sort of on stuff we've covered up until sort of the date we take it then? Okay. So if somebody else is already in there, it won't let us in? Okay. Okay. Mhm. Yeah. Okay. Sounds good. Okay. Great.